Hello, welcome to the audio-visual vox activity detection demo. As you can see, there are two predictions, one coming from the visual modality, the other coming from the audio modality. An off-the-shelf model called Celero has been used to get the predictions from the audio modality, whereas visual voice activity detection model or a VVAD model has been developed in-house to get the predictions from the video modality. Let us look at the correspondence between both these models. As you can see, two curves, one corresponding to the probability score using the audio model, the other corresponding to the probability score of the VVAD model. The VVAD model is quite robust to various lip movements and jaw movements and other activities. Let us take a look. Let us take a look how the information from both these modalities can be used together. For example,
of how generative AI is helping to evolve our products, starting with Gmail. In 2017, we launched
when there's a background speaker, the Celero model predicts that there's speech, even though the person in front of the camera is not the one who's speaking. Here is where the information from the VVAD model would be reliable, where you can detect if the person in front of the camera is the one who's speaking or not. On the other hand, in case like this, where there's a significant amount of background noise, the predictions from the Celero model seems to get quite noisy. As the background noise increases, the predictions of the Celero model are less reliable, whereas the predictions from the VVAD model are more reliable and independent of the background noise. What makes this VVAD model stand out is its robustness. It is quite robust to various head orientations and scale. Even in scenarios where the head pose is significantly different and not near frontal to the camera, the VVAD model is robust enough to predict if the person is speaking or not. So welcome back. Now let's take a look at how the models behave when there are more than one person in front of the camera. When the person who is being tracked speaks, we can observe that both video model as well as audio model have spikes in their probabilities.
Now the second subject starts speaking, but only the audio model's predictions get impacted by it. The visual model's output doesn't change because it's still looking at subject one.
Therefore, by combining the complementary information from visual modality as well as audio modality, it is possible to closely understand which of the two subjects are speaking.
BeSocial can process up to 5 individuals, tracking each face independently and storing their behavior data in separate buffers accessible through our API.